Assalamualaikum everyone. Welcome to my channel. Today we are diving into two super important ideas in decision theory, the extended independence axiom and the utility theorem, and how they connect to risk aversion and risk premiums. Now, I know it sounds technical, but stick with me. I'll break it down in simple, real-life terms, and by the end, you'll understand not only what these concepts mean, but also why they matter in economics and everyday decision making. In classical utility theory, outcomes are fixed in each state, but in real life, even if you know the state, outcomes can vary. The extended independence axiom or extended IA allows outcomes to be random within a state. Imagine you know it will rain tomorrow. Even then, it could be light rain or a heavy downpour. Uncertainty exists inside that state. That's what extended IA captures. Let's define an extended lottery. Imagine there are S possible states of the world. An extended lottery is defined as L is equal to F1, F2 up to Fs. Each Fs represents a distribution over possible monetary outcomes in state S instead of just a fixed payoff. For example, in state 1 there might be a 50% chance of earning 100 and a 50% chance of earning 200. This way the extended lottery accounts for randomness inside each state. What does the extended IA condition says? The extended independence axiom says that if a decision maker prefers lottery L over lottery L prime, this preference should remain the same even if we mix both lotteries with a third one in the same proportion. In simple words, preferences should be consistent and not depend on irrelevant alternatives. This property ensures rationality in choices under uncertainty. To make this concrete, let's take two states and two lotteries. In lottery L, the first state gives a 50-50 chance of getting 100 or 200, while the second state gives a certain 300. In lottery L prime, the first state gives a sure 150, and the second state again gives a sure 300. If the decision maker prefers L to L prime, then even when we mix both with the third lottery, the preference should stay the same. This shows how extended IA respects both the outcomes values and the uncertainty structure. The extended expected utility theorem builds on this idea. It says that if preferences satisfy continuity and the extended independence axiom, then there exists a state-dependent utility function. This means that for each state, outcomes are described by a probability distribution rather than a single fixed payoff. The expected utility of a lottery is calculated state by state, integrating over the possible outcomes, and then summing across all states. This allows us to represent preferences over complex lotteries in a consistent way. Now let us connect this framework to risk aversion and the idea of a risk premium. Risk aversion means that an individual prefers a certain outcome over a risk outcome with the same expected value. For example, given the choice between a guaranteed $100 and a lottery with a 50% chance of 200 and a 50% chance of 0, a risk-averse individual will choose the guaranteed amount. The risk premium is the extra amount that an individual is willing to give up in order to avoid risk. Put simply, it is the cost of peace of mind or the price of certainty. To illustrate risk aversion, imagine two individuals facing the same potential financial loss. Individual 1, who is more risk averse, demands a large compensation in order to accept the risk. Individual 2, who is less risk averse, requires only a small adjustment. Graphically, this is represented by their indifference curves. The more risk-averse person has a steeper curve, showing a stronger dislike for uncertainty. The less risk-averse person has a flatter curve,
showing higher tolerance for uncertainty. The difference in the required wealth adjustment show how risk aversion affects decision making. More risk-averse individuals demand greater compensation for the same level of downside risk. To conclude, the extended independence axiom and the extended expected utility theorem gives us a more realistic way to analyze decision making under uncertainty. Instead of assuming that payoffs are fixed, they allow us to represent outcomes as probability distributions within states. This leads to a deeper understanding of how preferences are formed. When you combine with concepts like risk aversion and the risk premium, these ideas explain why people make different choices when facing the same risky situation. Some are willing to take risks, while others demand high compensation to accept them.
Thanks for watching. If you found this video helpful, feel free to like.